Today we'll be going over writing and solving systems of linear equations using graphs and tables. We will solve systems of linear equations using graphs or tables by finding either the point of intersection, which is mainly used on the graph, simply where it crosses, or a common point, which is found on a table, and I will discuss in more details in a moment. In a system of equations, two or more equations use the same variables, so we'll be dealing with x and y variables, and intersect at a common point if there is a solution. Now this is a key part right here of if there is a solution. I'll get to that in more detail in just a moment. Now at the beginning, whenever I said that to solve a system of equations on a graph or table, we need to use a point of intersection. This is easily shown on a graph as the point in which our two functions cross at. I'm going to use an easier color to notice this. Both of my lines cross at this location. If I look at my values, my x value is over 1, 2, 3, 4, 5. And my y value has a height of 1, 2, 3. So we know that its point of intersection, where our two functions cross, is at a location, the solution, of 5, 3. When my x value is 5, both my y values would be 3. For a table, our common point is whenever our y values are exactly the same. So in this case, both y values are 3, which was our y value to begin with, when our x value was 5. Now, if we needed to create an equation out of this, our y1, we could look at our first 2 points to create the slope. We know that this is going up a value of 1, while our y value is going down 1. So changing this into a rate, this would be our negative x for our slope. So y equals negative 1x. And we are lucky enough to have our 0x value shown. So we know that our y-intercept value is a positive 8. So the full equation would be y1 equals a negative x plus 8, using our y-intercept and the slope of negative 1 over 1. We can do the same thing for our y2 value, still using the first point that increases by 1. Our y value change is going up 1. So in this case, we'll have 1 over 1, which makes our slope a positive 1x. We look where our x value is 0, and we see that our y-intercept this time is negative 2, so we show the minus 2. So this is how you can use a graph and the point of intersection to find our solution, or you can use a table where the two common points, our common y values, are the same to find our solution. Sometimes you're going to be given equations where we are not given it in y equals form and they want us to fill out the information. We still follow the same rules. We worked on creating or solving for y before and then putting it on a graph and putting it on a table. Following the same guidance, we want the point of intersection. It crosses at an x value of negative 4. and a height. I drew a little under the line. Let me fix that real quick. Our height of 3. If we can look over at our table, sure enough, it shows up where we need it to. We have repeating y values of 3 at an x value of -4, matching up with our solution. Now, in some circumstances, we're going to have it to where our equations simplify to be the exact same line. Both of these say y equals x minus 3. Whenever this happens, this means that all answers, all solutions are correct. No matter what our x value is, our y values will always be the same. For my line, our graph, it's a little bit harder to see because our lines are going to be overlapping on one another. So depending on if you have a colorized calculator, you're only going to see the top line shown. So this one's easy enough. As long as you have more than 1 point, you can pick the first two. And if their y values both match up, that is pointing to an infinite solution for your answer. For an equation, as long as we have the same slope and the same y-intercept, we will have infinite solutions. Now, if we have a situation where the slopes are the same, like this, where they're both -1/2 x, or I'm sorry, the slope is -1/2, but our y-intercepts are different, we will never see that our numbers are going to match up. If we were on the calculator and we scrolled farther down to our positive numbers or farther up in our negative numbers, we'll see that they never cross. And our graph will show that they're always equal distance at every x value that we meet. Whenever this happens, we're given no solution. Our lines will never meet. It's hard to tell on our table and graph because we could always extend farther thinking that it could cross. So it's easier just to look at our equation, show that our slopes are exactly the same, but our y-intercept values are different. That is the clear way to prove that there will be no solutions. So to recap on what we learned today, no solutions is whenever we do not have a point of intersection. Our lines never cross. We have no common value at any x point or x value. And the easiest way to prove that we have no solution is having the same slope but different y-intercepts. When they are the same slope and the same y-intercept, that means infinite solutions. This is easy to tell on our table because we'll have at least 2 different points where the y values specifically, are exactly the same. If 2 of them are the same in a linear equation, then all of them are going to be the same across the board. Our graph will be a little bit harder to tell because we'll only see one line. I say it's a little bit harder because if I'm zoomed in too much, even if they were different lines, I would only see that one, so it's hard to prove just by looking at a graph. And then the most common way that you're going to be dealing with this was when they do intersect and it is only at one location, 1 point. We use the common point, which means that our y values are exactly the same at one x value, or on a graph, it's our point of intersection, where the 2 lines meet.